Now we'll see what we have seen in the last lecture. So our first point is, in any system has zero initial condition, in that case the transfer function method will be used to calculate its output response when we have zero initial condition. Okay, when we have zero initial condition, at that time transfer function method is used. But if in any system has finite initial condition, in that case the transfer function method is invalid. Okay, so for finite initial condition we are not going to use transfer function method. Which method we need to use? That is state space analysis. Okay, so to get the output response we use state space analysis. And this output response should be the sum of zero state response and zero input response. Okay, now transfer function method give only zero state response, and in transfer function method you need to consider the input response as zero. Okay, so zero input response in transfer function method is zero, and you need to consider only zero state response. Okay, so zero state response is only considered in transfer function. So in transfer function method give only zero state response, and you need to consider zero input response as zero. Okay, now the past history of the system is described by state variable because there is some finite initial condition. So we can tell that the past history of the system is described by the state variable. Okay, and in electrical circuit, in case of in case of inductor, past history is described, or is the current through the inductor. Whereas in case of capacitor, past history is the voltage across capacitor. So in case of inductor, the past history is the current through the inductor, and in case of capacitor, the past history is the voltage across capacitor. What about resistive circuit? Is resistive circuit have some state variable or not? So the resistive circuit does not have any state variable because the output of the system, output of the resistive circuit does not depend on any past history of the system, because that is why we call resistive circuit as memoryless system or memoryless element. Now, what actually state mean? What is the exact meaning of state? जैसे कि हम लोग पढ़ रहे हैं that we need to analyze the state of our control system. So what is actually state? What is state variable? Okay, what are the state vector? Why we need to define these vector? Okay, how they are determining the state of our control system. Now suppose we got two variable, right? Before we got two variable, that is x1 and x2, right? So these were the two variables. Now the dynamic behavior of the system were determined by the differential equation what we have written earlier, which determine two variable, that is x1 of t and x2 of t. Okay, so these are the two variables which determine dynamic behavior. Okay, so we need to determine x1 and x2, right? With the help of this equation, we need to determine the value of x1 of t and x2 of t. Okay, now at any instant, suppose at any instant, if I am talking about any instant, it means the initial condition should have some finite value. At any instant, suppose when t is greater than t naught. Okay, so the state of the system is determined by this value at any instant. Okay, suppose this is at t is equal to t naught. After t naught, the state of the system is determined by these two variables, right? This is x2 of t and this is x1 of t. Okay, these are the states of the system. So after t is greater than t naught, the state of the system is determined by these two values, x1 and x2. Okay, so these two values, that is x1 and x2, is called as state variable. I will write it here, state variable. Now suppose this is the starting point at t is equal to 0. Okay, so this is the starting point where you will get some value of x1 and any value of x2. As t is greater than t naught, you will get some value. Suppose t is here right now. Okay, so we will get some values of x1 and x2, right? Again at t is at some point you will get some value of x1 and x2. So like this you can get the value of x1 and x2, right? Suppose this is the this is t1. So your system reach from t0 to t1, and before that you have determined the state variables which plot a path, right? So this is the path, this is the path. It is plotted by the state variable. Okay, whenever the t is greater than 0, it will take some value of variable. For example, t is greater than t naught किसी भी इंस्टेंट पे, सपोज एट दिस इंस्टेंट. सो एट दिस इंस्टेंट यहाँ पे कुछ x1 का वैल्यू आएगा, यहाँ पे कुछ x2 का वैल्यू आएगा. ओके, उसके बाद किसी इंस्टेंट पे x1 का वैल्यू आएगा, x2 का वैल्यू आएगा, x1 का वैल्यू आएगा, x2 का वैल्यू आएगा. तो इस तरीके से हम लोग इसके पाथ को ट्रेस करेंगे, ओके, प्लॉट को ट्रेस करेंगे. सो दिस प्लॉट ट्रेस अ पाथ, ओके, एंड at any instant with the help of this path you can determine the state of the state of our control system. Now I'll remove this. Suppose at t is equal to t naught, you will get some state vector. Okay, at t is equal to t naught you got some state vector. So this is x1. So this is x of t naught. Okay, and at t1 you will get some state vector, that is x of t1. So at t is equal to t naught, the state of the system is given by state of the system is given by state vector x of t naught, right? And at t is equal to t1, the state vector is given by x of t naught, sorry, t1. Okay, these state vector at any instant, if you have some state vector that is x of t, where t is greater than t naught and less than t1. Okay, so t is nothing but x1 of t plus, this is the vector, right? So x1 of t plus x2 of t. Okay, so these are the state variable and this is the state vector. So the state of any system at any instant is determined by state vector x of t. Okay, I'll mention here the state of any system is determined by state vector. You can understand what is state vector and what is state variable. So for nth order system, suppose there is input, these are the input, that is u1 u2 till u of n, and you will get output y1 y2 till y of p, and there will be some variable, state variable x1 x2 till xn. So okay, I'll write it, this is this as um. Okay, now how to represent this? So x dash n into 1 is equal to a. I'll tell you what this a and x dash is. So a, this will be m into n, and this is x n into 1. So x dash is differentiation of a state vector, and here x is state vector. A is your system matrix. So this plus b, which is nothing but input matrix, that is m into n, n into m, and u, which is m into 1. Okay, and you will also get output y in y was p, right? Yeah, so this will be p into 1 is equal to c p into n x n into 1 plus matrix d p into m, and this will be u, that is m into 1. So these are state variable and this is state vector. This B is input matrix, pi is output vector, and this is the differentiation of state vector, and this is the state vector, right? And A is your system matrix, U is your input vector, D is transmission matrix, and C is output matrix. Okay, now if you represent state vector in nth dimensional, if you represent state vector in nth dimension, then it will be called as state space. Okay, so what is state space? That is elements of nth dimensional space is called state space. Now next we will solve few questions which will help you to get the clear idea of this topic.